Hello up there! Sorry about that. I was just doing more maintenance. But that's always the case for good old Dr. Cortex, am I right? Well, it's good that you join us once again on our journey across the cosmos. And in good timing too. I just received my question of the day. So let's go ahead and answer that, shall we? Right. Now, today's question comes from Emily, and she asks, "Dear Dr. Cortex, how are meteorites made?" Well, Emily, that's a very interesting question. See, the meteorites which you speak of, they are solid bits of rock that are pulled down by planets by gravity. See, these rock bits in space, they clump together in sort of a gravitational force. You see, there are more to rocks in space than just planets and moons and stars. They're just simple boulders, basically, floating boulders in space. Now, once these rock bits clump together and they're traveling across space, just a normal day-by-day thing, then they're not called meteorites, they're just called meteors. Sometimes, if they're traveling at a really fast pace, then they are called comets. But when these big rocks are pulled down by planets, because they have a big gravitational force and they're pulling down everything that they can, then they are classified as meteorites. And sometimes there are several instances on the planet Earth, you know, where you can see meteor showers and meteorites. You know, those big balls of light just swooshing down past the stars into the sky. They're called meteorites, and that's what you're seeing in the sky. But anyhow, that is a very good question indeed. But we should not dilly-dally, for today we are looking at one of the most gorgeous planets in the solar system. And that, my friends, is Saturn. Get to move on, computer. Let's get some data started, shall we? Now, Saturn is, of course, named after the Roman god of time, and it's also named after the Roman god of agriculture. They're the same person. The Roman mythology really does have a lot of gods, don't they? This is just for all of you mythology experts out there. Now, from Jupiter to Saturn, several of you remember that Jupiter was the last topic that I discussed. From Jupiter to Saturn, there is quite a distance in space, pun entirely intended. For you see, the distance between the Sun and Saturn, it is 930 million miles. That's incredible. It'll take several years for a human being to travel that distance. Really incredible. And Saturn itself is a bit like Jupiter. Its diameter is about 72,300 miles, just a little bit below Jupiter's in size. Its rotation rate is about the same, you know. A day on Saturn is about 10 hours or so, give or take. But this distance right here, that plays a key part in Saturn's revolution across the Sun. For you see, it takes 29 Earth years for Saturn to revolve just once, mind you, around the Sun. It is really, really incredible. Now, as for Saturn's makeup, it's a bit like Jupiter as well, you know, with the swirling winds and the cool weather. Again, a bit like Jupiter. but a whole lot greater. For you see, Saturn has the highest winds of any sort of planet in the solar system. Take a look right here. The average wind speed on the surface of Saturn is a whopping 1,200 miles per hour. That's like... Remember when I talked about Jupiter, and when I mentioned the great red spot on Jupiter, that was about 400 miles per hour we're dealing with. This is nearly 3 times the size of that. That's incredible. And the temperature on Saturn isn't really quite promising as well, with about an average of negative 288 degrees Fahrenheit. But, with all that being said, Mars in its makeup is kind of like Jupiter as well, mainly hydrogen and helium. And as you can probably guess, it being the second of the gas giants, it gets more dense and more dense as you get inside the planet. And, as always, at the very, very center, about 10 to 15 times the size of the Earth, there is a dense ball of rock and ice. But it's really far down in the core of the planet. I mean, no thing could possibly get there. I mean, you would survive less than a second on the surface of Saturn. There's that space dust again. Oh well. Oh dear. Well, when you're really this far in space, the dust really sort of gets to you. Okay, I think I've got it out now. But, as I was saying, all of these statistics contribute to one thing, and this is a really interesting fact. Because of Saturn's rotation and wind speed, it is actually flattened at the poles. If you ever take a look at some pictures of Saturn, you can see that it's not quite the perfect sphere. It's sort of like squished at the poles. That is the reason why it is that way. Now, with Saturn being the gargantuan gas giant that it is actually the host for the most moons in our solar system. You might have remembered me mention in our Jupiter episode that Jupiter holds about 79, almost 80 moons in its grasp. Well, Saturn just about eclipses Jupiter in that amount. Just recently, an additional moon on Saturn has been discovered, clocking its amount at 82 total moons discovered. That is really quite amazing. Some of the major moons include Titan and Rhea. You may have heard some of those moons before. Titan, it has this dense atmosphere. You really can't see on the surface. It's a bit like Venus or really any of the gas giants, despite being the fact that Titan itself is a rocky moon. There's an interesting fact for you. But I'm sure many of you, if you know one thing about Saturn, what is it? It's these rings, these magnificent rings. You see, every gas giant has its own rings, but Saturn's rings are incredibly large. I mean, you can see them, you can actually see them from Earth with a small telescope, if it is strong enough. Now, these rings, they are made up of countless balls of rock and ice, some of which are as large as a full-sized house. But the unfortunate thing is, Saturn's rings are slowly growing thinner and thinner as times go on. So, look at that. There's Saturn and its glorious rings. Now, obviously, these rings aren't going to disappear in our lifetime. These things take a long hundreds of years to really dissipate. But we can look at its beauty from a distance. And that, my friends, is Saturn. Such a beautiful, beautiful planet indeed. And quite frankly, looking at such beauty can make one rather hungry. But, as always, and as many of you know, I'm sure that we can count on one, robot to help us. Hi, Shambot! Have you got something for us again?
I've got a sweet recipe to share, as a matter of fact. But by using the schematics I collected from Saturn, I created a most delectable treat I like to call Rings of Saturn. You'll need, let's see here, lifesaver gummies, strawberries, and wooden skewers. First, stick a lifesaver gummy around each strawberry, putting the strawberry through the hole of the gummy. Then, stick each strawberry on a skewer. Finally, put each skewer into your refrigerator so you can have a cool and sweet snack whenever you like. That's all there is to it. But back to you, Dr. Cortex.
My, what a relatively sweet snack indeed. Well, my friends, it's about time for me to go once again. And quite frankly, the computer was nice enough to go ahead and upload the next topic for me, so I don't have to remember it again like an old fool. Excuse me for one moment. All right, let's see. Oh, here's that slip of paper. And it looks like, my friends, we will be discussing the planet Uranus on our next segment. A truly odd planet in its structure. But, we go once again. A big shout out to Emily for the question of the day. Again, a very, very good question. Remember, the question of the day is still a thing, so to say. So remember to leave your questions down in the comments section below. Very well then. Ta-ta for now. Is a blast off, so to say. 3, 2, 1.